Hi guys, so in this session we are going to start up with the discussion of doubly linked list. So in the last classes we discussed about the linked list introduction and what is the actual linked list and what are the different types that is being present. So all those things we discussed in the last videos, right? So now this is one type of a data structure, there is one type of a linked list data structure. So we are going to see its representation, it's one of the example, how to insert a node, the middle, first or last node or whatever it is, because these are all very important points which they may ask in MCQs or in any type of competitive examinations. So without any delay, let me start my presentation, right? And I also request all the viewers who are watching my channel without subscribing, so please subscribe friends, so that it will be a great motivation for our team to put up more useful videos like this, right? So now this is the actual linked list representation, right? So what is the advantages of this doubly linked list is, so see, we have attached two nodes, see, front node and last node and a middle node. So in all the nodes we have represented three parts, right? So what is the use of using these three parts? So in the middle node, that is a middle part of a node, is used for storing a value, right? So the node which is present in the first part is going to refer to the address of the previous node that is being present. Then the third part is used to represent the node that is being present in the next side, right? So the advantage is we are using two pointers, that is we can track the node that is being present even in the previous. But in single linked list, we cannot able to do, isn't it? We will be able to accessing only the nodes that is being moving in the forward direction, right? So friends, frequently you just remember the chain formation for the linked list which I have given as an example, right? So you will be able to understand. So here we have used two hands for talking to the nearby person in this side as well as in this side. So the same is being used here. So as the previous linked list, we are using avail node. So what is an avail node? It is like a recycle bin. Okay, I have explained you already. So now this is going to hold the actual value. This data are all going to hold the actual value. So this last node is going to be your null node because there is no more nodes present. So this is the last node. So we are referring it as null. Okay. So now we will see the example. So this is avail, you can understand this. So this is the header node because this is the starting node. So we are linking with available nodes, right? So this is my front node. So this first node is holding the value 62, right? So it is present in the location x230. This is the address of this particular node, right? So now what is this node? So this tells you the address of the next node. This x751 is going to point to the address of the next node. So this x601 is going to tell you the address of my previous node. So this is my previous address, next address. So this is a representation, right? So what is the advantage of using this double linked list is, what is the meaning? So we can traverse in either direction. So it is very easy for implementation and for searching any node. Okay friends, so now we will see how to insert the node in the middle, last or in the front. Okay friends, so this is a new node which is going to be inserted in the linked list, doubly linked list. So how I am going to alter the pointers, you just see. So this is a new node with the address x709. So I am going to insert this node. So what I should have to do, I must have to insert in this area in between x601 and x230. So how I will be inserting? So first let me remove this pointer value. So what I must have to do is, I must have to change this next address. So this address must have to be the address of the x709, isn't it? Because next to this node node has to be coming, isn't it? So what I should do is, I must have to change this x012 to x709. So like this I must have to change. So what is the meaning? So this next address value is going to be this one, isn't it? Are you all clear? So now this is okay. So here in this location, the previous node of x709 has to be inserted. So what is the previous node of x709 now? Is this one, isn't it? So x230, so add x230 in this location, right? So once if I have given like this, my pointer will be moved to in this area, right? So now I must have to insert here, isn't it? So how I will be inserting? So what is the next node after this node? This must have to come, isn't it? So what is address value? x601 is the address value. So once I will be giving like this, so it is going to move here, isn't it? So now this is going to be your previous address. So now at this current position, what will be my previous node? This is my previous node of this node. So write this address value x709 and you move the pointer to this area. Can you understand? So total number of pointers, how much pointers I have changed? 1, 2, 3 and 4. Okay friends, so in the middle if I want to insert in doubly linked list, I must have to update 4 pointers, right? So very important point, make a note. Okay friends, so now we will see how I want to insert my node in my front and at the last by using the same node. Okay. So friends, now I want to insert this node in this last area. So what is the meaning? This node has to be the last node of this structure. So since this has to be the last node, shall I write here as null? Yes, I can write here as null and I will be adding here in this location. So like this you will be having, isn't it? So like this you are going to have. So now what is the previous address value of this node? As this is the last node, so this will be your previous node of this one, isn't it? So now I must have to write the address value of this. So x751. So can you understand? So now this null must have to hold the last address node, isn't it? Because this is going to be your last node. So this will be the node present in between. So the next address value will be x709. So x709. So once I have given like this, so my pointer will be moving like this. Can you understand? So now this has become your last node. And another point I just want to tell you is this last node always holds only one address. See, only one address it is holding. The next address node is empty, isn't it? So I can tell that this node as a one address node. So I can tell this as a one address node. So make a note friends, in all the linked list types, the last node will always hold the one address data. Okay friends, so please make a note in doubly linked list and circular linked list, this point is very important. So now we are going to insert the same node in the first. How can I insert? So you can try it by yourself. Can you try? Now I want to insert this node in the front location, that is a node previous to this, right? So what I should have to do, since this is going to be your first node, so let me write this as header. So this is going to be your header file, am I right? So header node. So once I have written like this, so this is going to point to the first location. So this will be moving to the node that is present in between. So now what will be this next value? What will be this next value? So this next value is going to be this one, isn't it? So what is the value? x230. So write as x230. Once I have written this, so the pointer is going to point in this location. Am I right? So x230 if I access, I will be able to get this data, isn't it? So now I want to update the previous address of the node which has been moved to the next location. So what will be this address value? This one. So x700. So once I have given this, so the pointer is going to access this node. So x700 is going to access this 1001 value, and this x230 is going to access this 62 value. So how many number of pointers we have changed? 1, 2. So we have changed 2 nodes. Along with this also will come, because once again we are attaching the header to a new node. So here we have 3 pointer replacement along with this avail node. Can you understand? So for the last node insertion I need 2, for the first node I need 3, and sometimes I may ask 2 also. You can write that also as the right answer. Then in the middle I need 4 pointers adjustment. Okay friends, so this is the way they will ask you questions. So, okay, so now I just want to tell you one point of avail nodes. Already I told it is a recycle bin. So it is used to store all the nodes that is being made for deletion, and nodes if I need I can also add from taking over here, right? So if I am going to take the nodes from here for addition, so the space of the avail node will decrease, right? So if I am going to replace all the nodes, whatever I am going to delete in this node, so what will happen? The space of this avail will increase. Make a note of it, right? If I am going to remove the nodes for addition, the memory space of this node will decrease. If I am going to place all the deleted nodes from here to this avail node, the memory space of this will increase, right? So now we will see some of the advantages and disadvantages of doubly linked list. Okay. So friends, these are all advantages and disadvantages of doubly linked list. So advantage I have written. So traversal is easier because we are maintaining the addresses for the previous node as well as the successive node. So the traversal is easier for doubly linked list. So next is execution of program. If you are going to implement by using doubly linked list, it is very easy because we are maintaining more memory addresses for each and every value. So we can easily retrieve the information, and time taken for execution is also going to be considerably less because of using 2 address pointers for referencing, right? So next, the disadvantage. So this they may ask you, make a note. And disadvantages, more memory. So it is going to occupy more memory spaces because enormous amount of pointers are getting stored in the memory. So because of this we need higher memory areas for storing those pointers. So deletion is difficult. Why it is difficult? Because if I want to delete one node, if I want to omit one node, I must have to adjust 4 pointers if it is in the case of middle, or if I want to if I want to delete in the first 3 pointers, or if I want to delete at the last 2 pointers. So because of this, the deletion process will go on exceed. Am I right? So next is traversal. Reverse traversal is difficult. Why? So friends, if I want to access from the last node to the beginning of the node, I must have to traverse each and every node, and then I must have to reach the first node. So it is a very difficult process if the nodes are really very huge in number. So that only they have given as one of the main important point. So reverse traversing is difficult. Okay friends, so in this session we have covered doubly linked list. So in the next class we will cover circular linked list, and we are going to discuss some of the important problems used for implementing these types of linked list, right? So bye and thank you.